Then we'll go in 2 minutes.
Yep.
Okay, let's start.
Yep.
Okay, ready? Okay, we'll start the webcast. Thanks all for joining in. I know it's quite late in the day in India, and we have a lot of visitors from all over the world joining us for this webcast. So we have an interesting talk lined up today. We have Ajin presenting his security framework for mobile application testing. So let me not take much of time. I'll quickly do a introduction of what Garage4Hackers is and what we do, and quickly pass it back to Ajin to take over. So who are we? Actually, we started way back in 2007 as an Orchid community. We are a bunch of people. We had a very humble beginning. The primary aim of us is, if you put it as a mission, is to take infosec education to the masses. So we promote free infosec education. And one of the ideas to have this webcast is to connect people who don't have access to researchers, to connect those two dots, and help people to reach out to the researchers and gurus, and get direct education from them. So what we do is we have offline meetings, but most of our bandwidth is pulled up into arranging this Ranjoda's webcast series. And this is our second year, and it's been good so far. And we have been able to present almost 10 webcasts this year. Okay, and apart from webcast, we do conduct regular CTFs. The one which we recently did was a mobile-based webcast. And apart from this, we do research into all crazy topics, right from cable TV, biometrics, drone security, lockpicking, fuzzing, etc. So you can, pick up on our research papers, exploits in our Garage4Hackers forum. And finally, we do have a human side to all this work we do. We also participate in charities, reliefs work whenever there is a whenever we think there is a need for us to contribute. And yeah, let me introduce today's speaker. Today's speaker is Ajin. He is the founder of one of the greatest OWASP, work Synoptic XSS exploit framework. He, directly syncs with our mission. So he supports free and open information security education. And please feel free to go to his website opensecurity.in, where you can find most of his research. And he's a prominent speaker in most of the conferences. He has recently presented in, Amsterdam, Black Hat, on and on. So thanks, Ajin, for accepting our invite and coming down to present. Uh, Before I could wrap it up, let me say a vote of thanks to our sponsors, partners, NetSparker, for helping us get this webcast all over the world. Thank you. So Ajin, I'm just transferring control over to you. Take over, please.
Hello.
Yeah, Ajin, take over.
This is Ajin. So Abeli actually had given an introduction about me, so I'm not going into that. So let's directly start with today's topic for this webcast. So today I'm going to talk about automated security and once again. APK, the IPA files, and you can also take care of your compressed Android source code, which are developed in Eclipse or Android Studio. Then again, it can actually handle the iOS zip source code as well. So in case of Android binary, the framework can actually do static and dynamic analysis. In case of Android source, it just does the static analysis. And in case of iOS binary and source code, it just does the static analysis. The Tyson support is on its way. Okay. So it's actually an open source project. It's free and open source. Yeah, you can actually contribute to it. A lot of people are actually opening bugs, asking for features and all those things. And the project is actually accessible via the GitHub link. So this link should give you the this is a repository for mobile security framework. And if you find any issues, you can actually open it here. So yeah, I'll just show it up. So it's very easy to configure. All the instruction, everything is here. So all the requirements, everything is mentioned. You can just take your time and go through it and see what is there for you. Okay, so setting up. So in case of for supporting Android, this one needs Python 2.7, Django 1.8, the Oracle JDK 1.7 plus. It actually currently supports. You can set this up in your Mac, your Windows, and in your Linux as well. And in case of iOS, like if you want to support iOS, you need to run this on a Mac. Otherwise, only Android part is supported. So there are some dependencies which are related with the which are related over the Mac, Xcode, tools, and yeah, let's coming to the static analysis phase. So as I told before, the framework is capable of doing two things. It can do static as well as dynamic analysis. So let's start with Android. So in case of Android, it can actually do an information gathering on the file. It can decompile the file to Java and Smalley. It does a permission analysis. It will check. It will also do a manifest analysis from a security perspective. Also, it will do a Java code review. Again, it will actually fetch information about the Android APIs that are used inside in the application. It does file analysis and a couple of other things like URL, email, file string extraction, etc. And finally, it will give you a report. So let's directly see like how the things work. So yeah, so I have my mobile security framework running here. So once you run the mobile security framework, you will get a web interface like this. It's very easy to use. All you have to do is you have to click here and upload your APK, binary, source file, whatever. So now let's select on upload and analyze. Let's select an APK. So I'm selecting an APK here. So once it uploads, you can actually track the status of whatever the process is happening on the console. So it will tell you like what all the things are happening. So when something bad happens, you can actually check here to see like what is the problem here. So in the console, you can see the things being done. So depending upon the size of the APK, the analysis take time. So this is the static analysis report. It actually shows you file information like the name of the file, the size, the hashes, etc. And application related information like the package name, the main activity, the target. I mean, these are all information extracted from your manifest file. And will also tell whether your native C kind of code is used or not, dynamic code is there, reflection is used or not, crypto is used or not, etc. And this graph actually shows a distribution of the different components of your application. So basically their activities, broadcast receivers, content providers, etc., services, etc. And here you can also see the complete Java source code. I mean the decompiled Java source code as well as the Smalley source code. You can click on this and it will show you the different files. You can actually like if you want to find particular thing inside a file, you can actually make use of this thing. And so if you give that, it will search for all the files which contains indent and will return back. So this is how the decompiled source code looks like. Yeah, so you can also go and check Smalley as well. So these are the Smalley codes if you want to check at the Smalley level. And because in some cases your decompiler actually fails, it won't be able to decompile and give you the exact Java similar instruction. So in that case, Smalley will help you a lot. And I'm not diving into like how to check those things in Smalley and all. Okay, let's stick back to the topic. Okay, so here in this field you can see a certificate information. So this is basically nothing but the certificate the certificate of the Android application, and this contains the key identifier, all those code signing information related with the with your Android application. So the significance of this is like so for a malware analyst or someone like that. So the first thing to look for whether an application is malicious, or like if you see like a lot of application stores are there other than Play Store, and they actually have a lot of application with the same name, even the same package name, everything is the same. So the only thing we can make sure to identify that it's a correct app or wrong app is by checking the certificate. So if someone tamper your application, or say for example you're working for a bank and your bank's application, you get it from somewhere, and you have to make sure that it is not tampered. The first thing and the one and foremost thing that you should check is the certificate. Who signed the certificate? So this certificate information shows the related information about like who signed the certificate. So if somebody modified it, he has to re-sign it. So that will reflect here. So this information is available for identifying the credibility of the application. And then it will actually do a permission analysis. It's nothing but it actually lists out the permission used by the particular application and give some status according to it. So this dangerous doesn't mean that it is dangerous, just that this can be used in a malicious way as well. So this is actually more concentrated towards malware researchers, malware analysts, etc. And it actually give you a brief idea about what this permission can do, like a little bit description as well. So for the pen tester, the takeaway is like you have to make sure that what are the permissions given here. Make sure that your application is never overplayed. Use only the permission that is needed by your application's API. Don't overplay your application. So that is one thing you can check and find out from here. Again, it will also do a manifest analysis. So there are a lot of security issues. I mean, if you don't properly configure manifest, they can like occur a lot of security issues. So the manifest analysis will tell you like what are the issues identified. So it tells that debug is enabled for the app. That means anyone can actually connect a debugger to the particular application and go through the different flows. That is not actually a good thing for a real world or production application. So you don't actually enable this flag. Then allow backup. So it's actually a debated concept, like whether it's a vulnerability or not. In some cases, it can become a vulnerability, like when you take a backup of the application, some data can also go with that. So all those things can come up there. And then it also tells about the activities. There are different activities here. This activity is not protected, and indent filter exists. So like you can an activity actually become exported when you specifically define Android export equal to true, or you define an indent filter inside it. So the problem with exported activity is that if that activity is sensitive or something like that, any application can actually invoke an exported activity. So inside the device, if your activity is exported, any other application running in the device can actually access that activity. So that is not a good thing. I'm not actually going in depth on that, because our today's topic is more around covering like how to use and find issues using mobile security framework. So it also tells there's a content provider. So you might be knowing like what is a content provider. So like it also tells whether that thing is exported or any other vulnerabilities related to any other vulnerabilities that you can find from manifest analysis. And I mean, like you cannot rely on a tool like for 100%, and you have to do it manually as well. So if in case something goes wrong, you can actually check your manifest and verify it. So here is a manifest file. So this will actually contain the exact XML representation of all those information which is passed by the tool. And again, it also does a code analysis on the decompiled Java source code. So this actually identifies some information like the application logs and information. So it basically tells that the application actually logs some information to locate. You make sure that sensitive information is not actually sent to there. And it also tells that file may contain hard-coded sensitive information like username, password, and key. So for example, if you take this crypto class.java, you can see that, there is a string key. This is a super secret key 1237. So basically for the demonstration, I actually use a vulnerable application, which is known to have some vulnerability. So actually you can see that this is a hard-coded information, which is actually available in plain text if you decompile the application. So such simple low-hanging things the framework can actually pick up. It also tell other information like application can write to external storage. So anything you write to external storage, the problem is that it's world readable, anyone can read it. And also it uses SQLite DB, and you can check out the vulnerabilities or attacks on that particular attack surface based related to SQLite. It will also tell you the APIs used by the application. So if you are doing a black box pen testing, you may not be knowing like what is the app supposed to do. So like you cannot actually go through a code review, directly jump into a code review to an application which you don't know anything about. So this is a better way of identifying like what this will give you an information like like what the application is capable of, or what it is, what it can do. Also, if you are a malware analyst, you can check in this way like what are the information, like what are the specific things which are related for a malware application which you can find from here. What are the specific APIs? By like what I mean is like the specific APIs. So all those information can be found out here, like what are the different APIs, etc. So this will actually give you a good hint on like what the application is supposed to do. And again, in the bottom, there is a URLs field. This actually will take all the URLs which are hard coded in this application. So since there is nothing there, it is empty. Again, same with emails. It also does a file analysis where it will check for SQLite DBs, then like hard coded certificates. So if you are doing SSL pinning and all, people actually hard code the certificate chain. So basically somebody can replace that. So that is not a recommended behavior. So such information, it will fetch, like if there is any certificates or similar information. It will also try to fetch out the juicy information, juicy strings from the strings.xml. If there is some sensitive information there, you can also find it here. And it actually tells the different files inside the APK. This is once you uncompress this APK, what are the different files here? And on the right hand side, you can see the activities, the different activities, the providers, receivers, services, libraries, etc. So these are the information you will get while doing a static analysis. You can actually generate a report of this one. Either you can press Control P and save it as PDF, or you can, for very long reports, it's actually having a bug, like either image generated won't be able to display properly, or else you can just click on this download report. It will actually, take a screenshot of the entire page and save it as a report. So it will be a PNG file. You can open it and use it for your purpose. Okay, so that is how you do a static analysis with the APK. Now let's see how you can do a static analysis on source code, zip source code. So if you are like doing white hat pen testing, you might be knowing the application logic, and you might be having access to the source code of the product which your company developed or something like that. So for that, what you can do is, like, this framework actually supports two of them. One is the projects which are developed in Eclipse, and one the projects which are developed in Android Studio. So you can see here is an Android Studio project. So what you have to do is you can just select everything, compress it and make a zip file. So you will get a zip file over here. Now what you can do is, like, you can actually upload this zip file to the framework. So I'm clicking upload and analyze. I'm going to Android and then selecting the archive.zip. Yeah. So that will basically gives a, it is very faster because you directly have access to the source code. And again, the same information you will get here. So whatever information is available, it will, is available from the source code and the manifest XML. It will fetch that and show it here. This is much similar to the previous application itself. So these are the different part. Here you can see the URL. It's actually trying to make a connection, like, to internal upload, something like that. Yeah. So this is all about doing a static analysis of Android application. Now let's come back to the slides. Okay, so let's talk about static analysis in case of iOS. So in case of iOS, we actually support static analysis of iOS binary as well as iOS source code. We don't have, the framework currently does not support dynamic analysis of iOS binaries. I'm trying to see, like, if it's possible, or like what are the different approaches on doing it. You can also, like, give your suggestions, because it's an open source project and you're free to contribute. Okay, so in case of iOS binary, again, it will fetch, like, from a binary we can only obtain very basic information, like the basic information about the binary, then the binary analysis result. Again, we do a file analysis. We try to get all the libraries, files, etc. Again, you have the report generation. And in case of iOS source code as well, the same thing is applicable. So, but the advantage is here, since you have the source code, you can do a code review as well. And then what else? All the things that are similar with the binary. So let's have a demo of both of them. So I go to the home page and I select upload and analyze. And there we have iOS directory, which contain an older version of Facebook. So this is an older IP of Facebook. You click on open. It actually does the analysis. So once the analysis is done, you will be able to obtain a report like before. Again, here also it tells the information about the file, the application related information, the version related information. And you can actually, if you want to see the info.p list, you can actually see it here. This will actually display the info.p list. And we also does a class dump of the particular binary. And this is the the particular class dump for that particular binary. So if you want to look for nested functions or any nested methods or anything like that, you can check here. Then we also have, the same thing. You can download the report of the page. And during the binary analysis, we use a couple of tools to determine the possible security issues. So here it tells that the FBI flag is not found. So basically, there is no protection, like, for against ASLR. And a couple of things like that. Some of the common vulnerabilities that you can see on an iOS binary. So it will report all those information here. So we do a binary analysis. Then we do a file analysis on the particular binary, like what are the plist files there. If you want to check out the different plist file, you can actually go through this one and select a particular file and go through the plist file, see if there is any sensitive information there. And it also tells what are the libraries used by the particular application. Again, it also tells out the files which are inside that binary. So in case of iOS binary, it's very primitive, because I mean we won't get much of information like we used to get from Android. So here it's like written in Objective C, and the decompiling part is very hectic. And in case of the Android, like you can easily decompile a Java file, easily decompile into Java or Smiley. Okay, so well, let's see how you can do with source code of an iOS application. So this is already a zip source, iOS source. You can just select it. It will upload it, and once the analysis is done, you will get a report here. So in this part, it will also do a code review, because you have the access to the code. Again, it will show you the similar information which is from info.plist file, and it also does a code review telling that it tells about some of the files are actually using banned APIs. So some string copy or something like that, which is actually banned, which can actually cause some buffer overflows or something like that. Then it does a primitive code analysis. So this code analysis part is yet to develop. A lot of people are contributing to it, and this is one thing that is evolving. So it will also it will actually tell you the different vulnerabilities identified during a code analysis. You can actually go to different files and see the particular source code of the particular file. Again, it will also tell us about the APIs which are used in the application. So similar to the Android device APIs, it will also tell about the APIs used. Here it will tell that there are local file IO operations is done, networking call is done, the web view component is used, and then it will also fetch out the URLs. I mean the different URLs which are seen in the particular source code. Again, it will also do a file analysis, and it will tell you like it will actually list out all the the different plist files, and also find out a particular certificate file here. So this means that some particular certificate file is hard coded there. So that's a good information you will obtain from this one. Again, if there is any library specific information, it will list out that, and also it will list out the different files in the file. I mean different files in the binary. Yeah. So moving on to the presentation, we actually talked about static analysis in case of Android binaries and source code, and also about static analysis of iOS binaries and source code. Okay, so let's have a look into the dynamic analyzer architecture. So currently the framework supports Android applications. I mean doing static and dynamic analysis of Android application. This is how the dynamic analyzer work. So we actually spawns a VM. It's an Android VM, and this VM is actually having our own agents which will do a lot of things in the background. And the dynamic analyzer will basically install the APK and run the APK, and it will invoke the agents in the VM. So every time you boot up a VM, it's actually loaded from a snapshot. So it's a fresh environment for the application to run. Again, to support like a lot of your application may not run on your on your particular VM. So in that case, you can actually connect your device. So you should be having a routed device with all our agents installed. So if that is the case, you can actually do the dynamic analysis with the device, which is much faster, and it will give you a better result. And again, this VM is x86. You have a choice of ARM, but it's very slow. So it's better to use a real rooted device. Again, so this is how the flow works. Initially, it will, as I mentioned before, it will install the APK, run the APK, and invoke the agents in the VM. And once you are actually, it will actually do an initial security analysis on the APK. Once that is done, you are allowed to go to the different flows, because the framework does not know like what is a particular flow. Like, does this application have a login flow? What is a credential? What should you enter to access this page? Where should you click? What is the correct flow, etc. So that part, it's actually, I mean, if you think about automating that part, I don't think like, it's very complex and it's very difficult. Still, things can be done, but still it's very complex and difficult. And so for that thing, it's like it will actually spawn the VM for you, so that you can go through the different flows of the application. I mean, different login flows or different execution flows of the application. And agents will capture all the information in the background, and it will send the collected information to the dynamic analyzer. So once the testing is done, we are also interested in the data that is stored inside the client side. So by client side, what I meant is every application is having an application directory under /data/data/ the package name. So there it will be storing its database files, its caches, other files, shared preference, etc. So we will also dump those information to the dynamic analyzer, and we will do a security analysis on those as well. And on the background, we'll also run an HTTPS proxy to to capture all the traffic that is being sent. If it's a hybrid mobile application, it will be connecting to a web server. So all those information we will be collecting to the proxy. So this is the basic architecture of a dynamic analyzer. And the code which I pushed to the GitHub does not have this dynamic analyzer because it's actually having a lot of bugs, and it needs a lot of improvements in a lot of space. So that's why the dynamic analyzer part is, the VM is not shipped with the GitHub link. It will be coming there soon once all these bugs and issues are resolved. So what the dynamic analysis or the dynamic analyzer can do, it basically takes a screenshot, it capture the decrypted HTTPS traffic, it will do a locate and dump sys, and it use some Droidmon API monitor to find out what are the APIs being called by the application and what are the information being passed through while calling those API, etc. Then it will also fetch all the information, all the URLs and emails which are dynamically invoked. So this is something interesting. So there are some malwares which basically will obfuscate their URLs, and what they do is while running they will combine all the string and invoke the URL. So by doing a dynamic analysis, you will be able to fetch all the URLs which are invoked dynamically, all the emails sent, and also dump the application data which I mentioned before. It also does a file analysis on the dumped application data, and it will do a report generation, and this is under development. So it's not as stable as other features. So now it's a demo time. Okay, so maybe this may not work, I'm not sure. Let's look out for the kindness of all the demo codes. Okay, so the one I'm showing is a real world vulnerability. So we have done the static analysis of do mobile app lock. So this is one of the common application lock that you can get from Play Store, that you use to lock different applications in a mobile. There are different ways to bypass this one. So again, I actually found an interesting vulnerability in this application. It's a pretty simple vulnerability. I'll be showing a demo of that as well. So, but let's start with the dynamic analysis. So here is my console running, and let's click on Start Dynamic Analysis. So basically, once you click that, that will actually spawns a VM. It's a snapshot of a VM, so it actually spawns a VM. And right now for the demo, I just configured everything here. Actually, it allows you to configure a lot of things, like some of the pre-settings that you want to make before installing and starting the testing. So once the environment is ready, you can actually click on Start Testing. So if you see on the console, you can see a lot of information happening there. So it actually starts ADB, and it connects to the particular VM, and it install the VM and run it. So this is the application open for you. Now you can set a password or something like that. You can go through the different flows of the application. So okay, I did the wrong password, I think. Yeah. So once everything is done, it will actually initially do a initial stat analysis over there. Now you can actually take the application and you can go through the different flows. Okay. And yeah, it actually asks you to save it. So let's save the email address there. Okay, let's close this application, and again we are taking it back. You can go through the different, so it's up to you. So there is an interesting option called forgot password. It will actually send the forgot password to yodelybangalore@gmail.com. So let's send the code. Okay, the code is actually sent. So the reset code should be sent to yodelybangalore.com. Okay, so in meanwhile, you can also do the different manual related test cases, whatever you want to do, you can actually do here. So our agents will capture the information in the background. So it's about you can actually configure this manual testing time, or you can do it automatically. So it will wait for a particular time once you have done with your manual testing. So once it is done, it will actually dump. There is some bugs here. Okay, fine. So once it is done, it will actually give you the screenshot of the particular application at the particular instant, and it will also show you the HTTPS traffic. You can download it, It will show you the logcat related information. You can actually check for interesting thing here. I mean, logcat is having a lot of information, so that's why we have the Droid API monitor logs. So here you can check for the do mobile. So this actually tells a lot of information about our application. Like it's trying to access the shared preference. Again, there's a lot of crypto stuffs going here. Crypto APIs are being called. Some information is passed, etc. So this gives a better understanding or heuristics on like what the app is performing at runtime. So again, I'm actually working to, this is actually a blank report. I mean, not all people will be able to go into a fair conclusion like what it is going to do. So I'm actually working to read this information and present it in a much better way. So that's why I told like this is under development. So this part is actually very informative. It will tell you like what the app does at the runtime. You can see like it tries to access the MAC address, and a lot of crypto related API calls are there. Again, it actually, what is it doing? Yep. So it actually tried to access the shared preference and all those things. So that is one information you will get here. Okay, so coming back to, which is it? Yeah, coming back to the results page. You have the dump sys log. If you want to look for something interesting here, you can actually see the dump sys log here as well. Again, you have the application data. So this is nothing but the data that is in under com dot slash data your package name. Okay. So again, it also tell you the dynamically captured URLs, like all the file schemas, all the URLs that are invoked dynamically. Again, if there is any email that is involved, that will be fetched over here under the email tag. And this is a decrypted HTTPS traffic. So all the decrypted HTTPS traffic is here. There is some interesting information here, which we will be coming into a while. Like there is one vulnerability here. So I'll come to it in a minute. So in the bottom, you can actually see the SQLite database. So these SQLite database are actually dumped from within the device. So all the databases created by the application will be shown here. These are the information. So basically, this will dump the contents of the framework will dump the content of the DB. So you don't have to do it manually, like connect to the device using ADB, then go through the different directory and do it. The framework will do it for you. So this is another DB. Again, it will also dump the shared preference. So the shared preference is having a lot of information like this. Again, yeah, it actually contains a lot of information. Then you have other files. If you want to have a look into the other file, you can actually check on that. Okay, so this is what you can do with the dynamic analyzer. Now I'll come to the vulnerability which I identified on AppLog. So you see that I actually click on forget password and send a mail. So this is actually the corresponding request for that. If you see here, the interesting thing is it's an HTTP request. So obviously this is vulnerable to MITM. Okay. Now, if you see the post data, you can see that it actually sends some parameters like action, the application package name, version code, IME. IME is 0 because it's running from an emulator. Then again, it's sending an email to yodel.com, yodelbangalore at gmail.com. And with for that particular request, you get a response like code MD5 is this one. So it's actually I actually did some analysis on this, and I found out that there is no validation on this email. So if you change this email to anything, you will get the reset code there. So how the flow works is like whenever somebody press that forgot password and click on send security code to email, this URL will be invoked, and a string of length 8 is generated, and that string is sent to this email, and the MD5 of that string is coming in the response. So that will be stored in the device. So when you enter that particular string in the reset code, what happens is like it will be converted into MD5, and the matching happens, and you can actually bypass this pin. So I'll show a quick demo of that as well, because that will be interesting for a lot of people. Okay, so here yeah, so what is this? So for doing the demo, I have to actually uninstall this one first. I'll uninstall this one. Okay, once I do that, I actually install the same APK. So I'm installing the APK. Okay, let's DB connect. Oh, installing the APK. So the APK is installed here. Now let's open the APK. Okay, now you have to initially set a password for this app log. So you're setting a password. It asks you to re-enter the password, re-entering, and you are actually saving it. Okay, so everything is done. Cool. So for doing MITM, I have to tunnel this traffic through a proxy, or I have to do a network interception. So what I do is I actually write a Python proxy, which will actually rewrite some requests. So this is how it looks like. So if the request URL is this one, you know, and get that request body and replace anything between email to email equal to synoptics.in@gmail.com. So the tool will basically, I mean, the proxy will, it's a proxy that will be, the traffic will be going through the proxy. And what the proxy does is like, it will actually listens for the post data and the particular URL. So if the URL is this, and it will actually change the post data, the email parameter of the post data with an email that the attacker control. Okay, this is what it does, and it actually send the request. So that is what the proxy does. So let's actually run the proxy. Our proxy is running. Again, let's see the logs of the proxy to make sure that everything is working. Okay, so proxy is running, and I'm taking the application. So now I click on forgot password, and I click on send the security code to security email. Send the code to security email. So the ideal behavior is that it should send to Yardley Bangalore at gmail.com. Okay, so you click on send code to email, and the proxy get activated there. So there is nothing shown over here. So it tells that this particular URL is invoked, MITM modifying the request parameter, and the email parameter is changed to the attacker parameter. So you can see that the post data is changed to this one. So if you go to the email, you should be getting an email there. Okay, so you can see the email over here. So if you enter that passcode over here, or 0R PIA XPB. So if you click on reset, yeah, you actually reset the code. So now you are in complete control of the application. So this is one very simple vulnerability which was identified using mobile security framework, which I wanted to show you. Yeah, so that's pretty much about the tool. I mean, what the framework is capable of. Now let's come back to the presentation. So these are some of the interesting facts about the tool. It's free and open source. It actually supports virtual machines as well as rooted phones with our agents installed. Uh, Again, it's a complete mobile application security testing framework. So that is a mission of the motto. And currently it supports Android and iOS. And we are actually adding support for Tizen as well. And one other thing is it will actually give you a very good reporting. So even if you are not the real tech guy, once you run this, you will be able to get I mean, again, you have to use your common sense there to find out like what is a vulnerability, what not is a vulnerability, but still it will give you a good fishy report. And the future plans for the tool is like to do the pen testing of the server side command of hybrid mobile applications. So you see the HTTPS traffic decryption and all that, right? So the future plan is like we'll fetch all the URLs, all the session, all the cookies, everything, and do a pen test on, I mean, the web app pen test or the server side pen test as well. And also to our exploitation module. Right now it actually shows the vulnerabilities, right? So now I'm planning to add some exploitation modules, like if things are going in a good way. So that is one thing about that is one feature plan. Again, we all know that last month we have a G4H mobile security CTF. So I heard about we have 2-3 winners, like about 2,000 people actually participated in CTF, and we have about 2-3 winners there. So I'll just give a quick idea, like a description about the CTF. So we had two APKs. One is a get secret APK and the send secret APK. And the entry point of the CTF was get secret. The challenge was to capture a secret that is sent from send secret to get secret, and use that secret to decrypt the particular AES key, which is a flag. So that was a challenge. So the vulnerabilities that you had in getSecret.apk is a hard-coded password. In the login activity, you can actually bypass that using, by decompiling and finding out the hard-coded password. Or else there is exploit activities, vulnerabilities as well. So ask secret and get flags are exported. So you can directly call, which basically bypass the login activity. And again, the issue was like logging sensitive information. So the secret is coming when the secret comes from send secret to get secret. It actually the get secret will log the information to the console. So that was one vulnerability there. These are the vulnerabilities which will help you to find the issues. Again, in case of send secret, the vulnerability was like there was an exploit activity called validate access. That activity was exported, so anyone can invoke that activity. And there is another logical vulnerability, like it will send the secret to any application which is having the package name OpenSecurity.getSecret and which is having the activity name getFlag. So these are the vulnerability. So one way of solving it is something like you bypass the login screen, you reach this get ask secret activity, and there if you find it, when the moment you click on one button, it will actually create a random number between something like 70 or 80 or 90, something between 60 and 80. There's a 2-digit random number. It will send to you. It will send to send secret, and in send secret, what it does is it will also generate it will receive this particular random number. It will also generate a random number and cross check this random number. So if both of this random number matches, so that is the trickiest part. So if both of this random number matches, it will actually invoke another activity called validate activity with a particular token, and this validate activity will send back the secret to get secret, which is actually getting logged to the logcat, from where you can actually, it will also invoke this ask get flag activity, which actually asks for a secret. So if you find the secret, you can put in the option or the edit text available in get flag and get the flag. So that is how the CTF was designed. I mean, to make it hard, we actually obfuscated the source code, and all the string except the login password was obfuscated. Like if you do a static analysis, you won't be able to obtain it directly. So like how to solve this? So there are a couple of ways to solve it. Obviously, the first thing is to reverse DexCard, find the logic, reverse the hard-coded secret to decrypt the APK and get the encrypted flag. That is one thing. Another is like you can bypass the login of get secret, wait till the random number matches. Like wait till because it's a random number generated with 80 and 90. So wait till your luck is there. And once the send secret send the data, sends a secret, collect the secret from the log and enter it in the get flag activity to get the flag. That is one way of solving it. The easiest way is to pass the APK and recompile it. Remove all those random number generation and string sending, and just concentrate on the logic and get it back. So these are the couple of ways to solve the CTF. And I'm very sorry, like I cannot cover reversing discard, which I actually promised before, because I have to remove the blog post. There is actually some issue. The license of DexCard is telling that you are not supposed to reverse the DexCard as well as its technology. So since we do not, even though we did not reverse DexCard, the technology is there in the APK, so you're not supposed to reverse it. So there's a lot of legal thing going on. So I would like to give my thanks to Garage4Hackers team to for giving me this opportunity to present this cast. Also, I'd like to thank my office mate Bharadwaj Machiraju. He actually wrote the proxy, so it's a very cool proxy. And you can contact me at Twitter or email or my website or whatever. So that's all from my side. Thank you.
Thanks, Ajit. We have few queries which have come in. If I can just send it across to you, would you be able to answer? Arjun, we have one question.
Yeah.
Yeah. Does obfuscation affect the app?
Can you repeat that?
Does obfuscation affect the app performance?
Yes, obviously it does. Obfuscation actually affects the app performance itself. So that's why most of the obfuscator, they are actually very lightweight. They cannot, do a lot of things, because like it can actually, cause a lot of performance as well. So these obfuscators available in the market, they actually think about security and performance. So their level of, like protecting or obfuscating is based on that. If you do too much of obfuscation and things like that, it will be it will actually partly affect the performance.
Okay. So we have one more query.
Yeah.
How do mobile apps prevent Google attack?
Hello.
Yeah, Ajin.
Hello. Can you repeat that question? How do?
How do mobile apps different from
Huh.
poodle attack?
How do mobile apps different from?
Different from poodle attack.
Poodle is basically something which is related with OpenSSL libraries, I think. So I think you need to configure your I mean the mobile SSL related clients to use a particular, I mean, which to an upgraded version or the one that does not have this vulnerability. I'm actually not sure what is the exact thing. So you have to check. I think it's related with the library. So you have to either add a particular, you have to use an OpenSSL library, OpenSSL related library which does not have this vulnerability. You have to update this thing.
Okay, so we have one more query, which is, are you using VirtualBox for running Android VM? Is that supported out of the box?
I'm actually running VirtualBox for, I mean, the current VM is hosted on VirtualBox. It doesn't matter actually. You can even run it on VMware or any other, virtualization tools you want. But what does he mean by, are you like doing it out of the box? I'm not clear at that part.
So this has come from Twitter.
Yeah.
So I'll request the guy to get in touch with you with a clearer question. Okay. So, Ajin, I think people can still contact you if they have any queries with the presentation or the demo. And would you be sharing the slides and the demos?
Yeah, I'll be uploading to SlideShare and send it via my Twitter handle, or I'll mail you the slides actually.
Thanks, Ajin. So thanks all of you who made it to the presentation. So you can keep on writing your queries with the hashtag G4H webcast. Ajin or our team will get back to you, and we will be putting up the recording of the webcast in another 2 months' time. Thanks for logging into this session. Watch out for our Twitter feeds. We will be coming out with more webcasts in the coming months. Some exciting things coming up, some exciting CTFs coming up. So keep a watch on our Twitter and Facebook feeds. And finally, I just wanted to thank few people who really took the effort to make this a real success. Sandeep, Imdad, Himanshu, and the whole G4H team. Thanks, guys, for helping out to get this webcast out. And thanks everybody for logging in quite late in the day to our webcast. I'm sure you would have enjoyed it. Please drop in your feedbacks. We always want to make this webcast a useful one, a productive one to everybody. So please drop in your comments. We take feedbacks, and we'll try to improve on it. Thanks for all joining in.